Oh, forgot I was muted because buddies came over last night, and I don't want to talk out loud. Well, talk out loud like a fucking maniac. So I did some of the problems while I was just quiet, as usual. Whenever that happens. So we finished up the quiz for. Oh, this is this optional ref something chapter. Before we did friend, classes, and member functions. So giving an entire other class access to your class's protected and private data members. Same thing with a member function of that class, so not the whole class. Some of that's kind of a pain in the ass unless you define the classes inside header files and implement them in CPP files, because that makes it a whole lot easier. Because then you just include both in one place, and cool, it's good. Alright, it's too hot right now. Fuck. Okay. Let's get it. Ref qualifiers. Is this where we learn, like, volatile, maybe? I don't think so. Because volatile... I don't know. Let's find out. Let's see what it is. Let's shut the fuck up and learn. It's not even long. It's super short. What the hell? Ref qualifiers. We had member functions returning references to data members. And I guess I'm going to go to C++ so I can, or to VS so I can think. If we had a class and we had a member function that was returning a reference to the member, I mean, it should be fine because it's valid. Meaning that in order to call the class, or sorry, in order to call the member function, the class has to be valid because it's not a static member function. Right, I mean, I'm pretty sure. Well, we don't even need this. Class dartboard. Oops, fucked up on the naming. Sorry. Okay. Excuse me. I mean, this is fine. Yeah, I mean, that's cool. Let's see. What if he saved it? Okay. I'll hold. The problem is we're losing the const, but now it's cool. Oh, whoops. This part. Well, yeah, these parts don't matter. And if we do this, then the problem is we're changing the type of the reference. Well, it's fucking misspelled. But if we put here, then it means, hey, we're not modifying this guy. Oh, wait. I'm actually curious what this error is. Oh, the point is, it's basically two similar things, or it was putting const here. So it's treating it as okay, yeah, similar thing. I'm not exactly sure how they're different or if they're redundant, but okay. And then what if we do another one? We'll do Oh, oops. Okay, and now we're gonna do x dot set score 4, and then okay, so 3 and 4. Yeah. Okay, yeah, I don't see anything crazy here. Not yet. So we can return references. Oh, that can be dangerous when this guy's an R value, meaning it's probably gonna have an issue here too. Oh, there's. Oh. Oh, hold on. So what's the problem here? The implicit object here is a temporary. It's just a dartboard, no name. Initialized with 3, and we're getting the score. But this result, the problem here is that this result is the value 3. Where do we actually get issues from this? I mean, if we save it, we're fine, right? Well, actually, the problem here... This piece of rice stuck in my throat. Oh, shit. We can actually... This is a reference? Wait, hold on. Yeah, this is a reference to this data member, right? Interesting. It's not dangerous in that case, I guess. But maybe I'm just lucky. Okay. So in this case, we're saying calling a function to create an employee. Also, in this case, we're passing a value to a function that is returning that class by value. But regardless, that's still a temporary. And so this is okay because we're using it in the same full expression. But then here, if we're saving temporary, I mean, right? Isn't that how that was going? This is a reference to an integer called y. It's being initialized with, or well, rather, it's being bound to. It's basically getting the address and automatically dereferencing. Excuse me, the data member score. Excuse me, from a temporary dartboard. Excuse me, so it should be dangling. Maybe I'm just lucky. Let's see if we can replicate this. But now we're doing make dartboard 3. Same result. I mean, it seems like it's still working here. Maybe I'm just lucky though. Okay, so we're creating this guy as a temporary, sure, but then we're printing it straight away. Versus creating a reference to this class object that then gets destroyed, which means its data member becomes or at least means that the reference to its data member is dangling because that object doesn't exist anymore. So if we use it later, it's undefined. In our case, it's working, but it's still undefined and not safe. An employee, it has a name, it has a constructor that creates the name with username, a C-style string probably, that gets converted to a string view. And then we also have another function. Yeah, that returns a reference to mname, same as what I did. And then we created a function that would do it. Oh, interesting. Maybe is it different at all when I create it differently? So if we create, say we return y, create dartboard y, initialize with x, return y. Same thing, yeah, same result. I didn't think that would change anything. But in case 2, the object is destroyed, yep, leaving it dangling. Yep. For getName returns by value, oh, makes sense. Well, but if we're only returning one thing, but isn't it still more expensive when returning by value? I mean, I guess it is by default, but returning by value means that we've created some sort of well, in this context where we're talking about temporaries, even if we're returning by value, we have created a temporary and assigned it value. And if it's a class type, that might be expensive, and the act of copying the value might be expensive. If we're returning by value, and it's sure like a fundamental type, it can be cheap. But if we're copying the value of a class type, it could be expensive. Compared to returning by reference, then we're just looking where that is in memory. There are no copies going on. So it could still be expensive either way. It returns by const reference. It's efficient because I'm not copying. Well, the point is we're saying if we're returning by value, we're copying it when we don't need to. It's existing somewhere, and it would be nice to just use a move semantic, I think is what it's called. Like a, copy. It's not culling. It's like copy. It's like diming or something. It's some funky word. But there's a word for when calls to the copy constructor, I think, or at least temporary, or at least I think that's the copy constructor, are not called because they aren't needed. So if I create an object and then copy it to another object and then return that second object, instead the compiler won't even copy it. It will just move where the value is in memory, I think, via a move semantic. I think that's what that's called. So that there's no copying. It's just, or maybe moving is moving the address. So instead of looking at this new place, which then needs value, it just keeps looking at the old place. So if we create x, create y, initialize y with x, return y, maybe it just looks at x instead. So yeah, if we're doing it by value, then the value exists somewhere, and now I'm putting it somewhere else. But if I only need it in one place and I just need to use it, then return by reference. The problem is if we're returning by reference, then we might get undefined behavior. It's cheaper, but it might be undefined because of dangling pointers and references in this case. Yeah, because if it's an R value, the object's destroyed after the full expression, and if you have a reference or a pointer, depending on it, well, undefined behavior, yo. These member functions are typically called on L value implicit objects. Yeah. Yeah, makes sense. Yeah. Basically just don't use references of, well, don't use the references later on. Don't store the reference as a reference. Store it as a value, maybe. Copy it. Excuse me. Well, if we're returning it by reference still, well, it's treated as the object. So doesn't that mean, does this even need to be? It doesn't. Yeah. See, I still don't even like passing by reference. It's really like receiving by reference. Because in that case, I just removed the reference, so y received the value and it was copied over. But if it was, if y still had the reference inside its type, then we wouldn't be copying it. So it's really receiving. Excuse me. And so, what is there a case that you add a qualifier to make sure that the reference is unusable if it's a temporary? One function to do something to return an L value and also for an R value. Problem is that we want one function to do it. So we want one function I'm not sure which function you're talking about. The ref qualifier. Oh shit, here's some. It's this and thing. Okay. Overload a function member. Gotcha. So we have a member. Oh, I understand. The point is this get name. If the this pointer points to an object that is non-persistent, it's a temporary, then it might return by value. But if it's an L value, then it can return by reference. So we can treat it the same way. We can return a reference, but maybe what it does actually depends. Gotcha. So we can have the right one being called instead of only one. We have non-ref. We can do it both ways. The problem is that it gives a const reference to a member, which is nice, a data member, when we have an L value. But when we have an R value, it's still doing the same thing, but then that reference will dangle if we save it. Add an and symbol, an and qualifier. Add a reference, I guess a reference qualifier for the overload for L values and a double for R values. That makes sense because I saw earlier that there are L value and R value references, and apparently we use double and for R value references, though I haven't seen that before. Haven't used it yet. Oh. Yeah, we're not touching it, so it can stay const there. And in one case, we're returning by reference, so we want it to be const, so we don't change it. And in the other, it doesn't need to be. It doesn't matter if it's const or not, because we're just copying the value over. Okay. So what does that look like? If we use it as if we use if the temporary one gets called, then it would be returning by value. Otherwise, it would be doing returning a reference to a persistent object, an L value. But getting tired. How does it work? Trying to remember my question. So if I'm storing this value though, if I'm storing it as a value, Does it not still dangle? I guess the point is that, give me. Like if I'm returning a reference to something, but that something is using the is of a value type. Basically, it's not a temporary. It's an. If it isn't a reference, then we have an object, a temporary object that was assigned value, and then it was copied over here. Or we have a temporary object with was assigned value, and we're just using this new object as an alias to it. It seems like it depends on what the actual call is doing. If the call, like if y, for example, with the dartboard, if y was an int reference or a constant reference, then what is it referencing if I call it with an implicit, or if I assign it or initialize it with an implicit value or an implicit object, class object that is returning by value? I'm assigning value to a reference. The reference is still being initialized. Oh, maybe it's going to give us an error because we can't have a reference to, well, if it's a const reference actually, then it would be a const reference to an L value, right? Or a const reference to an R value. And if it was a normal object, if we were receiving by value and we used an implicit object, it would just copy the value of the temporary. But if it was an L value, then we would be copying the value from the reference. Yeah, I guess it's safe in both cases, right? Isn't that how that works? I need some music to wake me up. I'm getting tired. My sleep was kind of whack. Messed it up a little. Okay, whatever. I had to just put that there. Well, for that guy, to answer his question real quick, I have a whiteboard over here. I had a whiteboard down there with shit that my buddy and I were writing for a game that we were making, just as like a test, because we had never collaborated for anything game dev, and he hadn't really made games in an engine and whatnot. Excuse me. And I made like some little stuff, a little test world. I mean, you can see it on my main channel. But on there, it says timeline from April 2025 to September 2025. So at the end of September 25 is the end of my C++ foundation. And then I'm switching to from October till March. So October, November, December, January, February, March, right? 6 months to create a C++ in Unreal Engine 5 portfolio. And then I'm hoping for a year to work at an indie VR studio and then boom, go somewhere big where they have whatever the state-of-the-art VR tech that I'm ignorant about is. Maybe it's a Pyrex headset with maximum FOV, the best graphics around, and all this kind of crazy stuff. I don't know. I just want to be with a team that, I'll just show them real quick, right? Battle Talent. Great freaking game. I played for a little bit a while ago, and I need to get it at some point, but it's this fucking sick VR game. Long story short, the combat is the most compelling I've ever seen in VR, and the move sets of the enemies are actually compelling. I mean, it's the closest we have to solo leveling. It's ridiculous. I mean, see, it's the best we've got. It's not perfect, but it's the best we've got, and it looks infinitely better than any melee combat I've seen in any VR game by far. Better than Blade and Sorcery, which I have. It's better, consistently uploading, and then you can look up Psydream, and boom, these guys are in Shenzhen, China, blah, 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 all the stuff, and they've been putting their hearts into this, and it shows. It's fantastic. They come over here, and I was looking at this yesterday, and they upload here when they upload with Steam. Not super often, but it's good. So these guys are great. I want to find a team like that and join them and start doing real shit. But I need to really break my ass for 6 months to start making compelling things. And not just, a proof of concept, a fully fleshed out product, just a really, really small one. So that I'm confident that I can ship something and finish something, release things and get them done under time constraints and do them well and push the boundaries and continue learning and getting better at things, just like Sandfall Interactive, where they hire a bunch of people who haven't released games before or haven't even worked in games before, but did programming in this or did music in that, and people who had experience, but not explicitly in this one area. I need to get my experience. That way I can pivot in, because none of them were, I had never done anything at all. I had no skills at all. It was all people who were working in like Ubisoft or other different domains where they were good at something. I need to get good at something. So once I'm good at something, boom, I'm going to move as fast as I can. And maybe I have to stay in my job a little bit longer. Maybe it takes more than 6 months. Maybe it takes a fucking year. Okay, I'll get promoted another time. I'll be hoping making some more dough and just saving the fuck up. And then at some point, the pivot will happen. And then I'll just be moving as fast as possible. Making good shit. Using my skills in my day. So that I'll finish up. I'll stop at 7:20 for the rant. Instead of okay. Ref qualifiers. Let's get the music going. Let me make sure it's muted. All right, it is cool. Oh, this is good. Okay. Ref qualifiers. Oh yeah. So as an example here. Oops. Oh, bro. Start with the main function, brother. So, temporary gun. Well, what's a thing I would actually do a temporary for? Like, let's just create a class called message. Ooh. What the fuck is happening? Ah, okay, gotcha. All right, class message. What do we want? Yeah, we can do that. Yeah, sure, that's fine. So let's do. Also want to output this. Okay. So we're gonna have this guy have a private data member. Okay. And it, whatever, has nothing. And then public message. It's created with well, let's just we create it with the standard string view. I mean, I guess that's the best way, maybe. I'm just gonna do a const standard string reference, it's fine. Okay. So the point here is we have one function that's an overload. It's an overload, and it returns a const standard string message, and the other returns a standard string message. The difference is the standard string message one needs to be returning literal so that we don't return a dangling reference, a potentially dangling reference in the case of an R value. So we need a const standard string reference for an L value, and it's called, oh, what do we name it? Do we put another reference here? I'll figure out the syntax in a minute. Get string, get message, okay? Const return message, okay? And then we have a standard string, get message, const return message, okay? But they differ by return type only, not enough. So, no, okay. Is it here? Oh, so it's here. It's between, okay. So it's between the full well, it's like the end of the signature, basically, is what's happening. Compiles. Okay. And now we could do two things. We could do standard character output, a message that is just hello, dot get message, which doesn't help. I mean, it's literally, we're passing hello into an object to then get hello from it, but it's fine. Message is an R value, temporary, calling R value overload. And then we have message, my message, sure. And it's hello. Okay. Well, yeah, sure. And then we could do my message, or dot get message. Two things here. Two objects created. One temporary message, one non-temporary, L value, R value, L value message. Using the get message for the L value, because this guy exists, these automatically have implicit this pointers. So this is really, what's really happening here is this. Is it just this pointer? What is it even called? I don't remember. Hold on. Oh, it's a, well, I guess it's a pointer, huh? I guess it's technically a unreseatable, hold on. So it's a pointer to a standard string, and it's unchangeable, so it's unreseatable. Okay, so it's a pointer to a standard string. It's not necessarily const. So it's really a standard string pointer const called this fuck. Wait. Well, I mean, I guess it's really this. This is already defined. It's already in there. So we could return the same thing, because mMessage is shorthand for an object that exists, its message. Well, luckily, there's a hidden this pointer in here. So what we do is we dereference that guy with the arrow operator, because it's a pointer to a message. It's basically an object is holding a pointer to itself so that its functions can dereference that pointer to get the object and then use member selection to get the value of the object. So it implicitly passes its values to its member functions. And we can call the member functions with their own names. So we're going to go here and we're going to see two things. We're going to see one, this is going to go down, and it's going to call this one, the R value version. And I should have put comments here, but I'm a fucking retard. R value overload, or ref qualifier overload. L value ref qualifier overload. Oops. Okay, so we're gonna see, boom, here it is. Create a message that's temporary. Hold. Initialize. Boom. Ah, fuck it. Hold. Oh, wait, hold on. Let's actually just run this thing first to make sure this is cool. Oh, hold on, stop. Okay, so it does that. All right. There it is. Okay. So what is it doing? Let's go back. Let's restart this thing. Hey. All right. So we're outputting something. All right, let's go and create a message. So we go to the constructor. For some reason, we go to the body first, but then we actually do the member list initialization. We go back to the body. Oh, there's nothing in the body. Okay, so we go back. All right, we've created the object. Ooh, now we're going to call its member function. Boom. We go to the R value member function because it has an R value ref qualifier overload. Boom. We return the value of M message. So we could actually store it and save it and use it and do whatever. Nice. And then we create another one. So we go, oh, okay, body, initialize, body, nothing. Boom. Go back. Stored. Now we need to call the member function, the L value overload. Boom. Boom. And boom. Nice. And it works. But we could also do const standard string reference my message, please. Hold. Oh, this is name my message too. X. Okay. But now, hold, we haven't used X, it's fine. So we would put sure. All right. So now we have X, and X here is a const, or well, it's an L value reference to const, but it happens to be getting initialized with a temporary, an R value, returning an R value. So, because this is a temporary standard string, if we ran this line and this was and used it as a temporary instead of actually storing it, then it would be gone. It would be destroyed. But in this case, we're actually saving it. And the reason is because this reference is allowed to prolong the lifetime of an R value until the reference itself goes away. So it's like it's holding it before it falls. So temporaries can get used and they fall. They come down, and they get used and then they fall. Oh, it got used and and then it fell. Or maybe it doesn't even get used. It just gets created and destroyed, created and destroyed, created and destroyed. An L value or a const L value reference can bind to an R value, and it can catch that R value before it falls and hold and use it. And then once the reference dies, they both go. And that's what's happening here. Okay, nothing special, but it's return type func name this guy or this guy, and then body. For example, we go to main, we create Joe. He exists and he's good. We're using Joe's get name, an L value. So we're going to get a reference to Joe because he exists. But then we're going to create an employee, Frank. We're creating a temporary, which gets returned from the function, and we're calling get name from the temporary, which means we actually need to get the value, because if we were using it as a reference here, that reference would be dangling after here. So, meaning if we saved it as a reference and then used it later, because you can't use it on the same line, then it would be dangling. So in this case, same thing. We have a name. We have the default, or not a default, but we have the normal constructor, and then we have two ways of getting the name. One returns for an L value. It returns an actual const reference to the L value. And I guess it is an L value because the data members of an L value, I guess, are an L value. So it matches an L value implicit. Oh, well, I guess we're not talking about the data member being an L value. We're talking about the implicit object being the L value. Sounds good to me. And then we would say a string, which can be an L value or an R value. It doesn't matter. It's an object, so it can be temporary or not. And it is returning my value. That way we don't have any references to temporaries, so there's no dangling going on. Yep. And it uses the double reference thing. The R value reference qualifier. I mean, we could have done that two ways. We could have just done employee initialized as Frank. We didn't have to do create employee. It still would have been temporary either way, bitch. You can do the performant thing when it's an implicit or when it's an L value, and the safe thing when it's an R value. Makes sense, yeah. Yeah, because it might be safer to do that when it's an R, or it might be more efficient to do that when it's an R value and use it by reference, but it's undefined behavior, so we shouldn't be using it. When the implicit object is a non-const temporary. Oh, and it's because it's const here? Somehow the consts are different? I think I forgot those. No, I did. Oh. Well, yeah, I mean, I was talking about this earlier. I mean, when we can negate copies and then just move it, that would be nice. So instead of returning a value that is copied, so now there are two copies of it, and that second value is put into wherever it needs to be, we could just return it a standard move something so that it actually moves the value into it. So there's no copy. Sure, there's still the assignment part, but there's no copying. And maybe the assignment's even easier actually, because you're just moving the value there and not doing extra checks, maybe. Yeah, so instead of getting a copy, you can try to move the member. It is because non-const. Oh, so that we can change it later on? I mean, it seems like if you were doing the temporary there, you could still do that even when it's const. I'm not super sure why it's. Maybe you can't move consts though. Because I think if they're unmodifiable, maybe they can only be destroyed but not moved. This can either coexist with an R value getter, so we have a const one as well, or we can just use this instead. Because we create a const dartboard that's temporary with no name. Hello? What's happening here? For a given function, non-ref qualified overloads hold for a function. Oh, meaning they need to be refed or not. So you have to choose how we want to do it. Okay. Excuse me. Meaning that the types, well, I'm kind of surprised that it's. The point is that if you're using ref qualified ones, you have multiple ref qualified ones, which means that they are distinct from each other because of their ref qualification. But if you have non-ref qualified ones as well, there's no distinguishing. It's only the compiler will look, and I guess it isn't able to say, hey, these guys aren't ref qualified at all. They're totally distinct too. But GG. And would that even make sense? I mean, it seems like if I have a given function, seems like either I care or I don't. It makes sense. Yeah, I mean, it makes sense. Oh, a const L value qualified. Gotcha, because that's the ref qualifier. So if it's constant, it's that. Then it can accept it. Interesting. Hmm. And we could delete them to stop the to disallow temporary implicits. That's cool. We don't recommend them because. Oh, true. Yeah, because you're doubling all the getters. Oh, Jesus. To mitigate against an uncommon case that's avoidable with good habits. Yeah, that makes sense. And if we have an R value overload returned by value, instead of just keeping everything by reference and not using them in shitty plays, we have to pay the cost to copy or move. Oh, because if we ever use it temporarily, we can't just use the reference one time in that one line and then the object's destroyed and then the reference is. No, because the object's only destroyed at the end, and the reference only becomes dangling at the end of the full expression. We can use it in that full expression. Standard character output, perfect example. Print the return value, or print the returned reference from a temporary. Cool. And then everything gets destroyed together and we're good. We're not using it anymore. It's never dangling. Nice. But in this case, if we overloaded the R value version, then if we ever called it as an R value, it would always make us copy. That's kind of bad. Use the result of an axis function. That makes sense. Yeah, that way when we need a value from a function, just copy it so it's safe and we know what's going on. Or use the reference straight away and don't save the reference because then it could be dangling. I like these quizzes. These are great. Thank you, Alex. You're an awesome guy. Does this say anything about Alex? It's just everything he made is great. All right. Let me do some push-ups real quick and then I'm going to do this quiz. I'm going to warm up for the one arms because I'm trying to also get a little bit stronger while I'm doing this stuff. And it gives the brain a little break. Oh, shit. Oh. I thought there was a screw on the ground. It was just a shiny little piece of thread. I swear someone came in this apartment when I was gone. I thought they were going to fix the door up, but my door started like rotting a little, I guess. Oh, okay, that was pretty good. I'll take it. All right, back to it. Oof. It's the perfect temperature for shirt off and fan on, honestly. All right, inside every hold on. Let me wake up. Oh, yeah. It automatically has this. Every one of them just knows this, which allows us to return the guy. So if we had, excuse me, some stuff that we wanted to chain, like what? How would we want to chain it? Ow! Oh, something that modifies it and then printing. Oh, yeah. How about... Yeah, that'll work. Please. Class gun, private, int m rounds left. Fucking default initialize it, dummy. And then we have the const gun referencing well, the point is we actually want the chaining first. Let's say we reload the gun, and sure, it returns. It returns this guy too. Okay. And then it return this. Okay. Oh, hold. This pointer? Hold. What? Hold. Oh. I mean, I get if it's a const gun pointer, right? Or hold on. Yeah. And then we're returning. Still no. What was the strat there? Is it just returning a gun? Oh, duh. Fucking return the dereferenced guy. Oh, okay. Jesus Christ. Dereference this to get the object itself and return a reference to it. Okay, that makes sense. All right, duh. Well, let's just say sure, actually this is fine. And then this one can just return. We'll do reload gun first. This returns nothing. And if we wanted to here, we could say this dot, or we could just do this arrow. Excuse me. Okay. And now we create gun X, and it has 17 rounds. Okay. And we could do X dot print rounds left. Okay, all right. We get 17. Boom. But then we could also do X dot reload gun dot hold dot print rounds left. And the reason that works, reload it with 28 rounds. A mag that's not quite full. The reason that works is because if this was returning an integer, or it wasn't returning anything, then whatever type of thing that it's returning, the call is returning an int, the call is returning nothing. I can't call print rounds left on an int. There's no int class that has a print rounds left function. You have to return a gun. Well, what gun are you going to return? Are you going to copy itself and do this shit? Well, in that case, it would be stupid. You'd return something that's initialized with this. Bro, return this. Return a pointer to this guy. That's it. Boom. It's the implicit this pointer. It holds the address, so we have to dereference it. Don't be a dumbass and forget that. Bro, there's some shit stuck. Alright, we're good. I need to chill in this informal slang. I need to wake up a little bit and become maybe more sophisticated. We can have functions return this by reference, yep, in order to enable method chaining. Yeah, that way we're calling print on this object. We're not copying this object. We're not returning a copy of this. We're returning this. And we're returning by reference. And honestly, passing by reference goes both ways. Because if you don't return by reference, you don't return a reference. If you return a value, even though you're initializing a reference with it, it's only going to get a reference of that R value. So it goes both ways. You need to, one, pass it by reference, but also receive it by reference. Sometimes. It kind of depends. Like, I think you need it for both cases. Actually, you don't. You really need to pass it by reference, return by reference, and then receive by reference. Functions receive by reference, because we don't have to pass a reference. We just pass an object. It receives by reference. But we do have to pass a reference if we actually want to, or return a reference if we actually want to return by reference. Yeah, because otherwise the member function is not returning that object type, so we can't call another member function on a different object type. We have to return the same class type, so return that object. Put the class definitions in a header file, and then define, well, the trivial guys can be defined inside the class, but otherwise we define them in the class implementation in a CPP file. Source file with the same name, yep. Go.cpp. Alright, I need another song. I need songs that just keep me freaking pumped up, so I don't get distracted. Oh yeah, I gotta, I don't. Right. The type that is defined inside a class type is a nested type. Cool. Oh shit, this one's busting. I love Noah, he's the best. Definitely needs to be in the I listen to this playlist. Oh, this is the oh, this one goes nuts. Type aliases can also be nested. Oh, so that we use the alias inside the class, but we can't use the alias outside. Makes sense. And nested is just including it inside the class. Member functions defined inside a class template that can use the template parameter. I would hope so. Imagine you have a class template that has type parameters or template parameters, but then the member functions couldn't, each one of them needed its own template clause. That would just be retarded. Member functions defined outside must get the template parameter definition. Yeah, I hate templates. Oh, you know what? I like them. I love them. Let's do the Huberman strat. Pretend that you like the thing to end up liking it. It should be defined on the same file just below. Yeah, makes sense. Keep everything together if it can be. Static member variable, meaning where it's relevant, keep it together. Static member variables. Oh, these are variables that are shared by all copies of the function. So there's one definition and they're all shared. And if they're defined outside, well, we could make them inline to define them inside. Or we could define it outside and it should still be like that. The difference though is, oh, it's kind of just convenient, I think. Static member, because either way, either there's one definition or there are multiple, but the linker deduplicates, so we're safe either way. Static members exist even if no objects. Yeah, exactly, because we call it through the scope of the class. Preferred access, exactly, by the class name and the scope resolution operator and the name. Duh. It's just like a namespace. It functions like it, and it's shared. So if we change it for one, so like let's say there's an aggro meter for all enemies in the game, and enemy is a class. Well, if I change the enemy aggro value via enemy : aggro value equals 100, then it's 100 for all enemies that exist in the entire everything. Static member functions, yeah, same thing. So it's a function that you can use for the class, but you don't use it on an object. You could do enemy name dot the function, but really you would want to do enemy : scope resolution operator, same thing. Function name. That way you can do something. Like maybe it updates the static member variable for all the instances. So update aggro, let me do that. Because otherwise, how are you going to set the static member variable, especially if it's private? Then you have to use a static member function that's public. They do not have a this, yeah, exactly. So if you wanted to pass something to it, you'd have to pass it a const, whatever, gun reference, so that it can access it. By default, unless you pass, and then I think so. Inside the body of a class. Is this true? Let's confirm this. Oh, they can't access normal. Yeah, because they can't. It's not for one object. I'm curious what the error is. Uh-oh. A non-static member reference must be relative to a specific object and it's in static. No, sir. Bump bump. Oh, oops. Uh-oh. Okay. Cannot refer to non-statics. That makes sense. Fuck, I didn't play piano as much as, well, I took pickleball over it. Ah, fuck, it was dumb. Excuse me. Inside the body of a class. A friend declaration is used, to tell the class that, hey, this non-member function, or member function of another class, or another whole class is a friend, and thus it has access to the private and protected members of this class. But not at this pointer, but still it can access. Cool. Oh. Wow. Ooh, it's all here. Ooh, holy. Oh, this is great. I like that. A scoped enum, okie doker. Include the monster types. Pop, 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 pop. Add an additional max. What? Oh, what? What are you talking about? A scoped enum. What are you talking about? Max monster type? Am I just stupid? Scoped enum of monster types. Cool. Different types. Nice. Another max monster types enumerator. So along with those others, I don't understand why we're putting in max monster types. I'm gonna... Oh. Alright, let's go in order real quick. Okay. Let's go with Denum. Okay. Cool. I don't understand the max monster types part. Okay, now we have a class. At some point, we're gonna nest it. Yes. Okay, and then we wouldn't want it to be scoped anymore. All right, monster. Class monster. A type. Oh. Yep, type. Yeah, we know this class is specifically only going to be used for the monster. We may as well just nest it. Makes sense. Public so we can access it elsewhere. Oh, fuck. Hold. I accidentally copied or what I didn't want to do. Alright. Oh, well, didn't need to do that, but it's fine. Okay, we're gonna now call this types. Hey, types. And now this is no longer unscoped, so we don't have to resolve it. Otherwise, we would have to put in types dragon instead of just using. I mean, we could do dragon, but it's not going to help. All right. It would implicitly convert, though. I mean, are you talking about creating max monster types just? No, I don't know about that. Okay. I was gonna say just so we can count because they knew that he knew that we were gonna make this an unscoped enum where it implicitly converts to an int. I don't know. Rename it to type. Oh, okay. Still cool. A constructor to initialize them. Okay. Oh, duh. These are named terribly. And honestly, I don't. Fuck it. I kind of want the P. Oh, this should be a standard string view so that we don't have to copy a string in here. Excuse me. Okay. And I still have to access this in here, but it's a nested type, so it's fine. So we could do... And we don't even have to use type. We can just get the value straight away because it's in the scope, because it's on the unscoped enum. Create a monster named Jimmy, and he is a type monster skeleton. His name is Jimmy. His roar is rattle. And his health is 4. Oh, nice. Hey, memory's working. Alright, lowercase. Fine, now fuck you. And what are we printing? Okay. All right. First, we need to get type string to get the monster's type as a string. Oh, makes sense. So that we can actually print the type. Yeah, makes sense. To get the type as a string. Okay. And this, yeah, I mean, I guess it'd be public, right? Yeah, sure. And then we say, all right, case dragon, or return dragon, case goblin, return goblin, case ogre, return ogre, case orc, return orc, oops, case skeleton, return skeleton, case troll, return troll, case vampire, return vampire, 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 case zombie, return zombie, default, return. Okay, so we can now get the type, and then now we're gonna do void print, takes nothing, const. Actually, how do we want to do this? Print each thing? What do we want to print? Name the type has health, hit points, and says roar. Okay. Need input output first. Really what we want are O-stream, well, O-streams and I-streams. I-stream, standard O-stream, but it doesn't really matter. We need to be able to use them. So we're gonna output name the get type as, oh, and actually this could be private. Get type as, oh, hold, wait, yeah, wait. Get type as string. I don't know why it wasn't populating. I must have mistyped. Type the something. Oh, wait. Okay. The type as string. The skeleton has, has something hit points, and yes, has hit points, and says okay, and now we can just call it Jimmy.print. Jimmy skeleton. And do we want to lowercase them? Fine. No respect. Fuck, I keep teeing. Jimmy skeleton has 4 hit points and says rattle. Okay, monster vampy, name monster vampire, vampy, hiss, what? His? I can see if it, oh, okay, I was like, he has a lisp or something? His, and then What? 3 or 8? 0. 0 hit points. Was he dead? Oh, he's dead. 0. So really we want to say this to this. And then we say if hit points is greater than 0, then the something has this many hit points and says this, else. What the fuck is happening here? Oh, oops. Has this hit points and says this, or we say is dead. Maybe the vampire is dead. Cool. And so, will we do 2 ways? We could say has. I mean, what? Do we do a fucking ternary? I don't. No, we can't do that. We can't do a ternary operator. No, ternary is returning a specific value and the types have to match. Right? What if we say true 4.31 or 2? Oh, oops, I just syntax was wrong. Oh, it actually could be different types, huh? But we can't call that shit there. Output. Yeah, no. Yeah, no, that ain't working. I'll take it this way, it's fine. Okay. And now we create a random monster generator. Because monster generator. Hold on. Create a random monster generator, meaning we create a monster and then we can print it and then it creates a random one. Create a monster generator namespace and a function that's generate and it returns a monster. And for now, make it actually return it's returning a monster. That's what's happening. Why are we putting in monster with all that shit? It's returning a monster, bro. And it's creating one. So it's oh, meaning wait. Well, so much for being random. Hold on. Oh, the point is for now we're just making it return literally a, okay, we're creating the structure. All right. I mean, in this case, let's just go ahead and start putting this where it needs to be. Excuse me. And the point is, this is using IO stream. Oh, I guess it. Okay. I guess we're getting some transitive inclusions here. Now, what do we actually want? We want constructor no body, so it's fine. No body. Or empty body. And then we could have this print function. Well, buddy, I hate to tell you. Now we're cool? Okay. I don't know why you're mad still. 55? There aren't 55 lines, motherfucker! Bro. Is it just a bug? I'm curious. Really? Really? That's what's happening? Okay. A monster generator namespace. And does that function need to be a friend? I feel like it does, but I could be wrong. Buddy boy. Sorry to tell you. Oh, now you're cool. Okay, you're fine with everything now. All right. Okay. Boom! It's working. Oh, and then we're just going to call those with a random number. Okay, so I see. I mean, I kind of wish that we should have just started this. Like, just say, create the thing from scratch. And this is about, I mean, this is exactly what I would have done. This is how I would have done it. It's a good idea. Alex is good. To get a random roar, to get a random name. Makes sense. I'm gonna put them up here. And these are getting standard strings, huh? Yeah. Okay. Easy peasy. Or we want 1 to 5? 0 to 5. Oh, inclusive. Okay. No, that's too cool. Oh, come on, really? Fuck. Sure. These are all kind of cool names. Alright, and then... Okay, that's where we'll continue next time. Bop.